Excellent.
All right, on Helu. From the 403 to the HAZ, Mr. Nelson here. I hope everyone's doing well. It's kind of scary right now. I put on my glasses so I look smart. They're actually kind of dirty, so I'm not. Okay, this is for my pre-cal 12s, and we are ready to start talking about logarithms, which basically naturally follows from exponential functions. So in the last unit, we were dealing with exponential functions, and our exponential functions look something like this. Y is equal to some constant, any number to the power of x. Our variable is the exponent. That's what makes it an exponential function. Okay, and the graphs of these, this was my, just make my Cartesian coordinates. So exponential functions looked something like this. We know all about exponential functions now, don't we? I'm sure we've had those drilled into our head. Now, the inverse of an exponential function reflects over y is equal to x, and that, the inverse, is a logarithmic function. Okay? This is a log, and this would be y is equal to log base c of x, and this would be up here, this would be, actually this would be, we'll just put it in inverse form. So this would be, if this was y is equal to c to the x, we recall when we're doing the inverse of a function, we have to basically switch the variable. So then this would be the graph of x is equal to c to the y. But we can rewrite this. If we solve for y, we get into logarithms, and we can rewrite this as y is equal to the log base c x. Okay? These are the same thing, but this is in my y equals form. So my logarithm is the inverse of my exponent function. Now, that's just the basics. This is just an introductory video just to let you know about why we learn logarithms, and then in the next few videos we'll start to play around with them. So why do we use logarithms? Where do they come in handy? Well, basically, in the world, sometimes, for the most part, we deal with arithmetic scales. So, if I had, say, time down here and distance up here, okay? Now, if I'm just driving a car, I'm kind of going a normal speed, I'll probably get, I'll get a graph like this. This is, and where my time is linear, it's 10, 20, 30, 40, 50, and this up here, this is going to be linear too. Let's say it's 1K, 2K, 3K, 4K, 5K, okay, right? So this is kind of a real world situation where, a regular graph will be fine for visualizing what's going on. Now, what would happen if instead of a car, that, I'm driving in a car, what if I was in like a spaceship that accelerates and continues to accelerate over time? So that, here, after 10 seconds we went 1 kilometer. Which is not right. Let's say this will be, I'll say 100 seconds, I'll say 200 seconds, just so that makes a little bit more sense. Still going real fast, we'll do that. So time in seconds, distance in time, okay? So 1K, 2K, 3 kilometers. So this is it. So if I was in a spaceship and I wanted to do the same thing, well, guess what? In 500 seconds, I'm going to go not 5K, I'm going to go more like 100,000K, just for example, right? So, and I'm going to start, I'm going to get faster as I go, right? So, I might be 1K here, but then the next data point at 200 seconds might be 10K, and then at 300 seconds, it might be 100K, right? So like, it goes way off the chart really quickly. So an arithmetic chart like this, or a linear chart, is not gonna cut it. So what happens here is we start to get into a logarithmic scale. Okay, so this is our time in seconds, distance. So now, to be able to visualize this properly, because we're instead of going up by addition, we're really going up by multiplication. I'm multiplying by 10 each data point, right? The same distance, and this represents 100K. So you can see that it's kind of funky, and this is called a logarithmic scale, and it's by order of magnitudes. Magnitude means it goes up, so this would be 1,000,000. We'll say 1,000,000 here. 1,000,000 distance in, I had seconds, it should be meters here. Okay? Kilometers, distance, okay, distance in meters. So in this case, this is a logarithmic scale, okay, and every time, so this would be 5K here, and then I'm going to split it in half again, that's going to be 6K, then I'm going to split it in half again. That's what the logarithm looks like. So it helps us to display information that would not normally be linear and kind of off the charts, and it helps us to basically just compact information so that we can kind of look at a chart more easily. We can basically bring everything under one chart. Where do we see logarithms or logarithmic scales in the real world? Yes, the Richter scale. So we know that on a Richter scale, we're multiplying by 10 each time. So a 1 on the Richter scale, a 2 is 10 times bigger than a 1, a 3 is 100 times bigger than a 1, a 4 is 400, right? It's not just 4 times the size of a 1. It's actually 10, 20, or 10 times 10 times 10. To get from here to here, it's actually 1,000 times stronger. Okay? And this is a logarithmic scale. Now, we still use regular numbers, but we know that a 4 is 1,000 times bigger than a 1. And that's why we use, and because there's such a massive range of strengths of earthquakes, that we needed a scale that can kind of compact all that information. So that's why we learn logarithms. And you know, when you get into engineering or sciences, you will get into situations where it's just going to make more sense, and it's just going to be easier to see what's going on if you put it into a logarithmic scale. So that is really just the introduction there. I encourage you to watch the video about the Richter scale to kind of get a better background, but that's it. So this was our exponential function. Now, if I was to take the inverse of this, I'm going to get my logarithmic equation. So if I do the inverse, I'm going to get x is equal to c to the y, right? This is not very helpful to me because I want to be in y equals form. So what we know, and I'm not going to derive it for you because I'm not a mathematician, but we know that we can rewrite this as y is equal to the log of our base, so little c, base c, x, okay? Where c is our base, it's our base here, and we also call it our base here. And this is our exponent. Y is our exponent, and this will be called our exponent, okay? That's it. So to start with this unit, we're just going to start by basically calculating a y when we're given something like this, and we can do that by basically knowing that this is equal to this. These are two different ways of writing the same thing. So whatever c is here, I can put it back in here. If I have an x here, I know that that's going to live right there. So what does that look like in practice? Well, let's try something. So let's say I have, I'm going to put it up here. Let's say I have, it tells me to calculate what log base 7 49 is equal to, okay? So I go there and I say, okay, I'm in my log form here. My question mark I can essentially replace with y. What I'm trying to calculate is my y. So to do that, I'm going to put this back into this form. So I'm going to say, okay, x is 49, so I'm going to get 49 is equal to, my base is 7 to the y. Right? Y is my question mark. So now I say 49 is equal to 7 to the power of y. Well, 7 to the power of what gives 49? 7 squared. That's correct. So 7 squared. So basically, the log base 7 of 49, which is equal to y, is equal to 2. So I could rewrite this as log base 7, 49, is equal to 2. And I could also write this is in logarithmic form, and I could write this in exponential form as 49 is equal to 7 squared. Okay, these are one and the same. Don't overthink it, it's quite straightforward. Let's do another example though. So, what if I had log of base 5, 125. And I said to calculate what is the value of this, evaluate it. Well again, I know that I'm in log form, and I'm going to convert it to this form. So I get, okay, 125, which is there, which is my x, whatever's beside my log, that's my x. That's my base, he's my base, so it's equal to 5 to the power of y. Now the question mark could have just been y here, because that's there, but we're trying to calculate y, so y is our variable. So to the y, or to the question mark. 5 to the power of what gives 125? Well, if I know my math, I know that 5 cubed. Therefore, this is equal to 3, which is equal to y. And I can rewrite this, so I can rewrite log base 5, 125 is equal to 3. If I want to put that in exponential form, I can rewrite it as 125 is equal to 5 cubed. Okay? These are the same thing. They're just written in two different ways, and this is our logarithmic way. And this is kind of just the baseline. So right now we're just evaluating it, knowing that there's a relationship between these two. So going the other direction now, if I gave you something like 36 is equal to 6 to the y, and I said write this in logarithmic form. Well, you go here, you say, okay, that's my y, so I'm going to put y here. Y is equal to, my base is c. So c is my base, that's my base, so it's going to be equal to log of 6, because that's where my c goes, and then x is here, so I'm going to put x there. Okay? And that's how I would write it. This is equal to this. These are the same thing, just two different ways of writing it. Okay, that's logarithms. And you can practice that, but let's do one last one here. And then we'll get into more difficult things. So I had log base 2 square root of 8. And I said that's equal to what? So now we have a square root here. That's kind of complicating it. But we're going to just follow the same process. So I'm here, and I know that my question mark must be my y that I'm trying to calculate. So I'm going to rewrite it. Square root of 8 is my x. So square root of 8, my x, there's my x, square root of 8, is equal to my base, which is 2, so it's equal to 2 to the power of y. Now I'm trying to solve for y. Now this is kind of where we have to remember what we did in exponents when we were solving exponential equations. So I have 2 to the power of something is equal to square root of 8. How can I solve for y? Well, if I can bring these both to have the same base, I know that the exponential rule, if c to the x equals c to the y, then x is equal to y. Okay, so that's what I'm going to do here. I know that square root of 8 is the same as 8 to the power of 1/2. Okay? But I also know that 8 I can rewrite as a base 2. I'm going to do that. So 8 is the same as 2 cubed to the power of 1/2, because I'm just converting that 8 is equal to 2 to the y. And then I'm going to multiply using my exponential law. I know that I have to multiply when they're like this, so I get 2 to the 3 over 2 is equal to 2 to the y. Now I have the same base, so I can just go ahead and write y is equal to, or I can go write the exponents 3/2 is equal to y. And I have solved for y. So I can rewrite this as log base 2 square root of 8 is equal to 3/2, or in exponential form, I can write 2 to the power of 3/2 is equal to the square root of 8. Okay? I'm going to pick it up in the next video. I think this was a good introduction, and we'll get some questions for you guys to jump through. All right, take care.